So welcome to lecture number 15 and unit number 4 of programmable logic circuit or programmable logic control of mechatronics. My name is Sachin Todkar. We are going to see introduction and architecture of programmable logic control in this lecture. This total chapter is related with PLC and its programming. So we are going to take 3 topics today: introduction to PLC, architecture of PLC, selection of PLC, and in next lectures we are going to see ladder diagram, then latching, timers, counters, and practical examples of ladder programming, because it is very important. As an engineer, you should know how to program the PLC. Now, what is PLC? PLC is digital computer for automation of electromechanical industry, because total all these industries nowadays are having electronics parts in mechanical components. So we have to do automation of these all parts with the help of digital computers, and PLC is nothing but a part of that computer automation. So wherever we use PLC, assembly lines, in assembly lines it is required. HVAC, heat, ventilation, and air conditioning systems we required PLC. Plastic injection molding machines we require PLC. Domestic and commercial washing machines. In your household also we need PLCs, programmable logic control. It is a member of computer family. It uses IC instead of electromechanical devices to implement control function. Now, what PLC is capable of? It can store the instruction. It can count the rotations or the things. It can have arithmetic logic. It can implement data manipulation. It can have communication skills or systems to control machines and processes and to adjust the timing. All these are functions of PLC. Now, what kind of working is there? Suppose there is one process or machine is there in your company or in your organization, and there are some measurements to be taken from that machine. That measurements will be fed to programmable logic control. That programmable logic control will give some outputs to control your machine or mechanism. So this is the simple block diagram of working principle of PLC. Oh, why PLC? Till that there were hardware panels were there, relay were there, but they are time consuming. They are having some time restrictions that consume time a lot. Again, second thing, that is they have repairing and maintenance issues. Main issues, these are wiring and repairing. So that's why we prefer PLCs, and the PLCs give you faster controlling. They operate in real time. They withstand vibrations, temperature, humidity, and noise. Inbuilt interfacing input and output systems are available in PLCs. Flexible, easy to reprogrammable. You can easily reprogram it anytime. Easy to maintain, less space is required, less wiring is required, and that's why they are cheaper than the hardwired relay system. Now, selection criteria. Firstly, we have to consider the application requirement. What is actual application of that particular PLC programming? Then second, that is, you have to consider input and output requirement. What kind of inputs are there and what output you consider you want to generate. And third is your memory requirement, how much memory it will require. And fourth one, CPU requirement, and the last, that is the software you want to implement. So that last one software requirement. So these will be the selection criteria. What kind of application you are going to use in PLC? Input outputs. What are the inputs and outputs given from the PLC? Memory. What kind of CPU is required and what kind of software is required? So these will be the selection criteria for selecting any kind of programmable logic control. Now, what are the input devices? Just now we have seen that is input output requirement is there. So what kind of input devices are used in control system? So the control system will require take limit switches, open close kind of comparators to compare the signals, and the last one, that is push buttons, press or not pressed. So these will be the input devices. Similarly, output devices, they accept output from the control system. So that will be light on off system, motors, rotating and non-rotating motors, and solenoid valves engaged or disengaged. So this will be the outputs of PLC. You can see in one slide the symbols of input and output devices, that is PB1, PB2. So this is push button ones. LS1 limit switches 1 and 2. Then pressure limits, pressures setting 1 and 2, temperature limit and level limits. So these will be some inputs of that PLC. Outputs will be motor, it will run or it will stop, solenoid valve engaged or disengaged, light, this R, if it is R is written, it is a red, G is written, it is green. So these will be the output devices for the particular PLC. Now we have to see some relay sequences also. Firstly, control sequencing, safety, central locks in automobile system. Before PLCs, we were using relays, cams, timers, etc. So we might be knowing that in automobile industry, cam and follower system is used. Now we can use PLC to modify that cam and follower systems output. Timers they were using in previous eras. So physical relays used in circuit instead of ladder diagram. Event sequence is done through wires, relays, and circuits. For changing event sequence, rewiring is required in that case. So these are the disadvantages of a relay system. Sometimes it is necessary to add or remove relays. So from relay to computer-based controller, that is PLC, how we have moved, we'll see. Input and output variables are binary in nature. So control relay can be replaced by softwares. Less hardware control is required. Program sequence can be changed through software only. You can change softwares anytime. Special functions, for example, time delay, counters are easy to change through software. And that's why we use programmable logic controls. Now we'll see what is the architecture of PLC. What we mean by architecture? Architecture means we are going to see what is the actual structure of PLC. So in PLC, there will be input module, there will be programming software, there will be one microprocessor or big processing unit, and there will be output modules. Input, programming, processor, output. These four are the main functional architectures of PLC. Now, what are the other components we'll see? Input module, output module, CPU, memory, power supply, programming device, and communication channel. These are the main components of PLC, and we are going to see one by one. Input module, these are input modules, just like limit switch 1, push button 1, limit switch 2, etc. These will be your input modules of PLC. Module examines state of physical switches, other input devices, conversion of signal into suitable form of which is suitable to the processor. It can accommodate number of input channels. Conversion of real world voltage and current that PLC can understand. Different type of input devices, hence different type of input modules are required. Digital module, analog modules. Discrete digital module, that is 0 to 0 or 1 states. Analog module use number to show state, that is 30 degree, 40 degree, 50 degrees, temperatures, etc. So it may use switch 24 volt, it may use pressure device, it may use temperature device. These will be the input modules of PLC. What are the output modules we'll see? Here they have shown relay, motor, resistance and limits. Output module supplies AC power to devices like motors, lights and solenoid valves. It accepts 0 or 1 from processor and uses it to turn on or off the lights and motors. Output module channel has indicator to show on off of operations. So these are the output modules. Maybe they will use fan, light or wall. Processor. Processor is nothing but computer. It executes a program to perform operations given in ladder diagram. Now, it performs arithmetic and logical operations that we are going to see: AND gate or gate, NOR gate, etc. So these are logical operations. Arithmetic operations will be there: addition, subtraction, etc. Output given by processor depends on input variable data. Now CPU. CPU is nothing but the brain of PLC. We know for computers also, CPU is very important. It is required. Logic and sequencing functions. Uses microprocessor. Memory contains program of logic, sequencing and other input and output operations. Memory ranges from 1K to 48K words. RAM, ROM, EPROM, erasable and programmable. EP means erasable and programmable ROM. Power supplies. There are two types of power supplies, which is mounted on the side of chassis or which is mounted in the slot of chassis. So there will be power supplies in PLCs. There are two types, that is fits into one slot of chassis or external power supply, or third one, there are three actually. Third one is standalone, connected to PLC or input output through power cable. Now the programmable device, which is detachable from the PLC, can be shared with different controllers. Types. There are types are simple each pendant type devices, PLC programming keyboard and CRT display. Programming keyboard can be used. And the last one, that is communication channel. So to communicate the data, their channels are required. They are called as buses. Information is transmitted in binary form. Data bus, sending data between constituent elements. Address buses to send addresses to locations for accessing stored data. Control bus is for signal related in internal control action, and system bus is communication between input output ports and input output units. So this is the diagram of communication channel. You'll see here there is address bus, which is communicating address. Control bus is communicating control systems. Data bus will deliver the data, and input output system bus. So input output system bus is nothing but it is communicating with input and outputs to each and everything, between input output ports and input output units. So this is the brief glimpse of PLC, we can say. We have not seen any programming today because basic things are to be cleared first. We are going to see ladder logic from Monday onwards, and will write some PLC programs for specific applications in next lectures. Till then, if you want to ask any questions, you can ask me right now, or study well, and you can ask in Saturday, Sundays also. So you will get all the points cleared. We'll meet again in next lecture on Monday. Sachin Todkar is signing out. Thank you very much. I'll just